Welcome to Algebra 2, Semester 2, Unit 12, Section 7.1. This is the very beginning of this unit. This is page 1 of our notes. Before we go into the actual math part of this, I wanted to share with you how cool exponential functions can be. They're pretty useful. Let's say, for example, that when you come to class tomorrow, that you make a bargain with me and you say, hey, Miss Kane, for every minute that I work math, would you give me twice as many Skittles? I say, well, how many Skittles do you want me to start with? You say, well, let's start with 2. So I clarify. So every minute you work math, I give you twice as many Skittles as the minute before. Well, how many Skittles would you have in, say, 5 minutes? We use exponential functions all the time out in nature and in statistics because they really do occur a lot. So let's say the first minute you get 2 Skittles. Well, you work math the second minute. So now you get 4 in the second minute. Well, in the third minute, I have to give you twice as many as the minute before. So now in the third minute, I have to give you 8 Skittles. Well, now we're talking about a lot of Skittles as we keep going forward. Because now we have the first minute, try to get it in the view. We have the second minute, the third minute. Now I need twice as many as those 8. So in the fourth minute, you're going to end up taking from me there were 8 there, so I've got to get 16 out here. I don't know that this will fit on my viewfinder. 2, 4, 6, 8, 10, 12, 14, and now 16. Okay, so a lot of Skittles. Well, now what happens in the 5th minute? Well, in the 5th minute, you're going to get 32 Skittles. A whole bunch. You've emptied my entire bag of Skittles. Now you think back, well, how many Skittles did you have altogether? I don't know, but before you come to class, I'm going to go ahead and have a Skittle. So, this is how exponential growth functions work. And we've dealt with these quite a bit in graphing. If you remember back to the very first unit that we did, you did a parent function. And that parent function went through 0, 1. And the parent function was y equals 2 to the x. And so every time we went 1 to the left, we increased by 2. So here, 2 to the 0th was equal to 1. 2 to the first will be 2. So it goes twice as high as the one before. Now we go 1 to the left, it's going to go twice as high as that 2. Now, like the Skittles, you would go clear up to 8. If we go to the left, I'm sorry, I think I said to the left before. My dyslexia is showing. It's when we go to the right that they double because it's growing. If we go to the left, we're going to cut them in half. So our graph, our parent graph for this, looks somewhat like that. Now, when you see these graphs in this unit, you're welcome to go back to your parent graph and realize, okay, well, what I'm basically doing is I'm just manipulating that parent graph slightly, and instead of every one to the right being an increase by 2 times, or doubling, now I'm going to go 4 times. 4 to the 0th is still equal to 1. Every number to the 0th power is 1, so we always cross at the 1. on the y-axis, but now 4 to the first would actually be up here at 4. And the next one would actually be 4 squared up at 16, way off of here. If we go back, it's going to be at 1/4, and it goes lower and lower. So it really stretches up fast. Okay? On the next one, remember back to our parent graphing, how the negative caused it to flip over the x-axis. So normally if this is increasing by 1 1/4, it's going to be a fairly slow trend. It's just going to be coming up just a little bit above and just shrinking down. It's almost like a straight line. Over time it curves. But now this has a reflection. So make sure to draw it down here. Okay? All that I'm wanting is sketches that you understand where this is going. Now on the next one, it is probably best to go directly back to that unit. If you've forgotten it, watch a few videos. This is your A value, this is your H value, this is your K value. Okay, so a light sketch of our parent function, it went through here and it doubled like so. So now we're going to go to the, remember H's are opposite of how they appear. So instead of 1 to the left, it'll be 1 to the right, and go down 3. So 1, 2, 3. It's easiest for me to just take that point that it crosses at the 0, 1 and actually move that point, we call it a vertex, over 1 to the right and down 1, 2, 3, and make that point again. Okay, now it's being stretched by 4. So the easiest thing at this point to make sure you get the graph correct is just choose the point x equals 2 and plug it in. 2 minus 1 is 1. So 2 to the first is 2 times 4 is 8 minus 3 is 5. So at this 2 value, you're up at 1, 2, 3, 4, 5. Okay? Let's make sure that we have this correct, because I believe it may stretch up as well. So let's just plug it in and verify that it's in the right spot. We know that that's where the axis has moved to. But let's make sure that we've got this right, because I think it will stretch up some. So we plug in 1. 1 minus 1 is 0. 2 to the 0th is equal to 1. 1 times 4 is 4. Minus 3 is 1. So it does stretch off of the axis. See, the axis would be right there. And normally, if we just had the minus 3 without stretch, it would cross right there. But because we have the stretch, it comes off the axis by a factor of 4. Okay, let's plug in our 0. See what 0 does. 0 minus 1 is negative 1. 2 to the negative first, remember from your exponents, is 1/2. 1/2 times 4 is 2. 2 minus 3 is negative 1. So it's right there. So far we have this on our line. Now we could go ahead, we know that our axis is down here, we could go ahead and draw that curve in. Okay? Just plug in a few points even after you've pictured it, just to make sure that you've got it in the right spot, because that really helped us on that stretch. Now over here I put it in words. We have a shrink factor of negative 1/2. Oh, I'm sorry. Oh yeah, I see where I got the negative. It's reflected. So negative 1/2. The b value of 2, and it shifted 3 to the left. So by b value, I mean the k value. So it shifted 3 to the left. We would have, oh, I'm sorry, no, the b value is right here. These are exponential formats, and I apologize. I was just doing the mx plus b form in the Algebra 1 video, so I was thinking of the y-intercept and the k values. Okay, so shrink factor of 1/2, it's reflected. B value of 2, we have it raised to the x, and it shifted 3 to the left, so that would be a plus 3. We don't have a k value, evidently. So if we picture this, where it's got the b value of 2, we know it's still a growth. This is the parent function going like this. We're going to reflect it, and we're going to shrink it by 1/2. So shrinking by 1/2, the points would be half as close. Reflected would be that it's down here. But now we need to shift it 3 to the left, so we're going to back up and go 1, 2, 3. And now we just simply move what we draw right here, this reflection like this. We're going to move it right here because it's 3 to the left. Okay? Erase or lighten these other lines so that I don't get confused, and you can show me what the true answer is. Okay? Okay. What I really like about exponential functions, not only do we get to play with candy in class, but we also get to work with compound interest. This is such a life skill to understand. Study this formula up at the top. A is the amount in the account after however many years we have it there. P is the beginning amount or the principal amount in the account. R is your annual interest rate. It's always expressed as a decimal. N is the number of times that it's compounded per year. It will tell you that. And T is the number of years. So let's do a few problems together. Okay. Underline the important things, marking what letter they are. First, let's recopy the formula. A equals P, 1 plus R over N raised to the NT. Aren't you glad you didn't have to develop that formula? It's a really handy one to use, but luckily we don't have to prove it and develop it. Okay, you deposit $400 in an account. That means that's your principal amount. It pays at 2.92%. Switch that to a decimal. You move the decimal place over 2 to the left because you're dividing by 100. So that is your R, your rate. Find the balance after 1 year. That's your T. And it's compounded quarterly. Quarterly means 4 times per year. And that's your N value. Okay. So now we can start plugging things in. We're looking for the amount in this account. We have the principal 4,000. Bring down the 1 plus our R value is 0.0292. We have that it's compounded quarterly, which is 4 times a year. We're tracking this for 1 year, so we bring up that it's 4 times 1. Okay? Now, you really do need to just go right to a calculator to plug this information in. I generally will double check it. You can put the whole string in, but sometimes I will double check. And I'll put in 1 plus, and then put this in parentheses, 0.0292 divided by 4. Then I take that answer and raise it to the 4th power. That answer is 1.0073 raised to the 4th. Now, it's fine to put it in there in an entire string, but sometimes I see students make errors on that. So double check your calculating and make sure that you come out with this answer, 4,000 $118.09. I did have to round that off. Okay, so make sure that you get the right answer. Practice with your calculator for just a minute and see if you can get that. Okay. Next problem. The only difference on this one is we're going to say that it's compounded daily now. How many times is that? Well, if it's compounded daily, and we're looking at a year, if you said 365, you are absolutely correct. Okay? We switch our R to a decimal, 0.0292, just like up above, and it's still the 4,000 for your principal, 1 year for time. So let's see how much more money you might make if it's compounded daily. Compounded means the interest is evaluated, added in daily. Okay? So, go back to our formula. A equals P 1 plus R over N to the NT. Plug in our values. 4,000, 1 plus 0.0292 over 365, and that's raised to the 365 times 1. Okay, go ahead and plug that in a calculator. Preliminary numbers are 1.0008 to the 365, and I got $4,118.52. So compounded daily didn't really get you that much of an advantage. A little bit of extra change, but not a lot. I'd like you to do number 3 on your own and have that ready when you come to class tomorrow. So we'll talk a little bit more about interest when you do that. So go ahead and have that one. The only thing you want to be careful of, let me line you out on something. Your T value on this one will be 3, compounded daily, so your N value is still 365. 4%, so your R value, move that decimal over 2 places, 0.04, and 2,000. Make sure and check with me, make sure that you have that right before you start into your equation. Or start into your bookwork. Go ahead and solve that one. Thank you. We'll see you tomorrow in class.